I put this video together for people building portable projects that require a light yet powerful, uninterruptible power supply like the ones found in laptops, phones, and Roombas, and wanted to use lithium-ion batteries but are afraid to because of the obvious risks like massive fiery explosions due to simple mistakes like over or discharging. Anyway, the most difficult part of this for me was just figuring out what power parts to use. When it comes to battery charging, there are so many protection boards out there. PCB, BMS, CMB, UPS, and if you know nothing about lithium-ion, good luck figuring out how to use each of those boards in your projects. Because legitimately informative documentation containing real-world examples is sparse. So let's use this project as an example. I needed to power a Raspberry Pi, IP camera, 2 motors, and a few other peripherals off a battery that can be charged at the same time without disturbing anything. Now this could be easily accomplished with lead acid or NiCad, just add a voltage source directly in parallel to your battery. But my goal this time was to be as light as possible, so I was determined to go lithium-ion. It took several tries and a few close calls, but I eventually figured out the right combination of parts to make this work. 18650 lithium-ion batteries are by far the most common, readily available, and are 3.6 volts each. And since I needed at least 12 volts of unregulated power for the motors, I knew I needed at least a 4S configuration. That's 4 cells in series for a nominal voltage of 14.4 volts. Next is a protection board to prevent all that bad stuff from happening. At first I wanted a CMB, or charge management board, which is supposedly the holy grail of lithium-ion charging because it's got a balancer, polyfuses, and a charger all built in. But it turns out I could only find one of these by a reputable seller on the entire internet. They're expensive, and they're not uninterruptible. Like, if the batteries or power are removed, it shuts off its output until the load is also momentarily removed. Not what we're looking for in this project. Eventually I figured out that I could use a PCB, or protection circuit board, as these are much cheaper and don't interrupt when charging. I just had to make sure I found a power supply rated exactly for a 4S battery, which for charging is 16.8 volts, not 14.4, which is confusing because the max voltage of each cell is actually 4.2 volts. The 3.6 volts mentioned earlier was only the nominal voltage, like the average, or where it plateaus. The charger also had to have enough available current to run all the equipment in addition to charging the batteries at the same time. In this case, I found that 2.5 amps was sufficient. Okay, so looking back at the example circuit from before, now we can fill in the unknowns. We've chosen our batteries, a protection board, and a charger. Also, as you can see, if you disconnect the charger, the load is completely unaffected and the batteries take over. Finally, after several days of continuous testing, I found that everything is still running cool, and that the supply voltage with the charger and batteries connected to the full load sits at 16.94 volts, which is 4.23 across each cell, which is the absolute max allowable charging voltage. So this shows that we are successfully running the whole system and charging the batteries at the same time. So there you have it, a down and dirty crash course on one plug and play lithium-ion charging. Peace out, y'all.